Hi everyone, 1:30. Let's get started. First of all, thanks for everyone coming to this room. And for those who doesn't know me, I'm Daniela Petruzalek. I'm a product owner at JPMC. And as you can see, this is not about my day job. And basically the idea here is to build this indie game in Go. And I'm not claiming to be an expert in indie games or game development at all. This is more like, that's why what I try to say as this is a devlog, is sharing my process, what were my learnings, and yeah, let's see what happens. So first, talk a little bit about the motivation behind this exercise. Then, of course, I'm going to explain the game rules, and then we're going to see some code and see how things are stitched together and the end results. So, I used to work for a company, probably some of you, if you're based in London, you should know, like it's called GopherCon, a fintech. And they had this motto, like, always start with why, and I really love this. Because this in a sense of, well, yeah, if you're asking why, not to be annoying, it's just because you need more context to evaluate things. So basically, why I'm building an indie game. So I have a plan. I'm going to develop a game in Go, then phase 2, and then phase 3, profit, of course. Easy, right? So, and of course, if you're old enough to know where this reference came from, yeah, I know, booster shots are coming to you. But anyway, the truth is, as I told you before, I'm a product owner now. I'm basically managing a team. So I got too far away from code for my own good. So I decided, okay, let's do an exercise. Let's work on some project that I can practice a little bit my coding skills. But I'm that kind of person that I don't get very excited very easily with APIs and things. So I decided, okay, this is my free time. Actually, I want to do something fun. So yeah, let's build a game. But then when you start developing, like researching Google game development, you get overloaded with all these complex platforms like Unity, Godot, and Unreal, and it's kind of like overwhelming. And when I'm in a learning process, actually, I don't want to know everything and be exposed to everything. I want to start simple. And I was even researching some smart codes about constraints, and of course, as is internet, like everyone disagrees, like probably this was Leonardo or Michelangelo or nobody, I don't know. Very likely, no, it was neither of those. But basically, this is a principle I like to think of. Like constraints help you be creative, help you find ways to work around things. So that's how. Also helps you learning overall, because when you start riding a bicycle, you put some tiny wheels before going for the real thing. So I decided to start small, and constraints usually are pretty good. Like if you know this is Hollow Knight. It's probably the most successful indie game story over the past decade, and everything starts with a game jam. And game jam is something that's very common in the indie development community. Basically, they set up a team and say, yeah, you need to do a game that has a team X. In this case, the team was beneath the surface. So Hollow Knight started, it's an amazing game that started just with the concept of, yeah, things need to go down. Imagine, this is like the power of a constraint. But yeah, what are my constraints? So my brain doesn't work in 3D. So yeah, must be 2D. 2D space is good. Must be written in Go, because Go is fun. Go is the language I like the most nowadays. Must be doable by one person, because I'm very busy. I want to do this on my own time. And it's nice to have a team, but actually this is all about like this last item. It must be a learning experience for myself. So yeah, on my own pace, I'll be learning things. And also, of course, the desire is to do a complete game. Note that I didn't say a big game, I said a complete game, which is different. So it's small, but should be playable. The game. If you're new to game development, this is kind of the process we go when we want to create a game. So we have an ideation process, brainstorm some ideas, write some game design documents, then start prototyping, test, and iterate. Like eventually you're going to productionize and release your game. I'm mostly interested in, like I said in the beginning, I want to develop my tech skills, like just revise some coding. So I kind of want to skip these processes. And the best way to do that is reuse something that you already seen before. So I did this already. This is my shameless plugin. This is Pac-Man from scratch. It's a Go tutorial which I wrote a couple years ago. It's designed to teach people the Go programming language while you're rebuilding Pac-Man. So I already done like an action game in the past, so I decided, okay, this time I want to do a card game. So I picked one card game that I knew very well. This was from my childhood. Actually, this is I'm showing this, maybe, I don't know if this game exists anywhere in the world, but this existed in my childhood. Like, it's an 80s game called Around the World, translated to English. And it was inspired by Jules Verne's Journey Around the World in 80 Days. And basically, the goal is to reach 40,000 kilometers. Like, you have travel cards, you play travel cards to reach 40,000 kilometers. And the thing is that you can only play travel cards if you have the right terrain. So you have a boat card, and if you are like in land, you can play boat. That's basically the game. And you need to be in a state that's called oriented. You need to know where you're going. And then there was the fun start to happen, because other players can throw hazards at you to take you out of oriented state. And also they can play land cards on your field to change your modes of traveling. And you can basically also play hazards on other players, or you can play terrain cards on other players' field, or your own field to improve your travel condition. That's kind of the gist of the game. So this is how the playing fields look like. So you have basically travel cards here. They are the number cards. You have the battle stack, where you have green cards are the good ones, red cards the bad ones. The terrain stack that controls your movement. And you also have this special class of cards that are the defense cards. There only exists one of each kind. And basically, they prevent other people from throwing one hazard at you. So, for instance, if you have, there's a hazard called epidemic, but if you have the health card, it prevents you from getting sick, basically. So these are the cards. So battle cards first. First one is orientation. Second is lost, and that counters orientation. Here you have the guy working and end of money, like out of money, and escape and hostile tribe in a free translation, and remedy and epidemic, and the corresponding blue cards that they protect you from these things. Also, these are the terrain cards and the travel cards corresponding. So the worst one is this desert thing that you can only walk on foot. You have savage land, you can have foot, horse, or balloon. Sea, only boat or balloon. And civilization is any card except both. And there's only one card that's the most powerful card in the game, is this blue card. That's called alternative routes in English. And basically, if you don't have this card, every time someone throws a red card at you, you need to put the cure to that status effect, but also you need to play on an orientation card on top of it, so you can be oriented again and start playing and start moving. If you have this card, this alternative routes, you don't need that. You can move without an orientation, and also it cancels all the terrains. You are not restricted to terrain effects anymore. So this is kind of like the most powerful card in the game. Okay, these are the basic rules, so let's try to see how to patch these things together in a game. And I'm using, like the process I'm using, like this is a very popular process in Brazil. It's called Extreme Go Horse. And basically this has several axioms, and this is the most important one. It says there are 3 ways of doing something: the right way, the wrong way, and the extreme go horse way, which is exactly like the wrong one, but faster. So, and that's exactly what I was trying. I was trying prototyping. The thing about gaming is that the feedback tends to be visual. I know In my work, I'm very precious about test-driven development and things like that. But here, actually, you know when things are not working. Of course, tests will help, but unfortunately in games, you can't test everything. It's really hard to test drawing images and make sure you have drawn the right thing. So you can see, in the end, my test coverage is around 50%. It's because most of the drawing routines are not tested. The tools, we're going to use Ebiten, which is this amazing library written by Hajime Hoshi. And basically, its focus is a very low-level API for 2D game design. And also, it supports inputs, drawing, a lot of sounds, and these all low-level things. And it's very interesting because it's also cross-platform. You can build for Mac, Linux, Windows, mobile, and etc. And also, you can, more recently, you can do also bindings for Steam and Nintendo Switch. So it's kind of like, I think they're still publishing the first game for the Switch, which is called Beers. Okay, I forgot the name. But still, they are publishing a game on Switch with this tool, so it's kind of really cool. Okay, Ebiten 101. So, if you know about game development, usually you have something called the game loop, because games are essentially, they run into infinity until you get bored and turn them off. So, Ebiten, the way Ebiten works is you have this game object that needs to implement this interface. And the interface has only 3 methods: update, draw, and layout. So, update is where your game logic should live. Like, it's where you update the game state, basically. Draw updates the screen. Layout is for scaling and resizing the screen. So the thing is, both update and draw, they're called, on average, 60 times per second. So they should not be blocking. They should be calls that end pretty quick. Just update the thing. And draw is something that it always redraw the entire picture. So just be mindful of that. So let's look at some basic code. So this is, let's see, I think the font's good. So I created the very minimal Ebiten hello world you can write. So an empty game struct, empty update method, empty draw, layout, just return what was passed to it, and I'm calling run game. So if I build this, oh, sorry, wrong folder. Go build, and hello world. Ta-da-da, should take a while, and then you have a big black screen. Not very exciting, but it is working. Basically what you do, I wanted to draw something, let's do print some text here, Ebiten 2, debug print, hello, oh sorry, one, hello GopherCon. So, if I do this, what did I do wrong? Oh yeah, I forgot to say that I want to write this to the screen. Okay, go build. And we are going to see just a tiny text saying hello GopherCon. Yes, very tiny because that function doesn't allow me to scale the font. But basically, this is the idea. Every time, and that will run forever, and because the engine is just calling over and over, draw, update, update, and so on. Okay, this is kind of nice, but we're not seeing a lot. So let's start drawing some things. And then we have some utility functions to load files. Basically, there are 2 things you need to know to draw an image. First, of course, you need to load the image. And there's the ebiten.image that implements the image interface. And also, the draw image operation, they just take an image object and this image options part. And this is, instead of saying draw this image at X and Y, you are going to use the options object to perform some matrix operations on it. And basically, scale, translating, rotation, everything you perform using this op. And you have the geom, that's for geometries, and have the color that you can apply transformations to the colors as well. So let's see example number 2. So let's build it. Example number 2 is exactly the same thing as the last one, except like I'm using just for fun mutex ons just to load the image for the first time on update, because if I didn't do this once, I'll be loading this image over and over and over. And also in draw, I'm just saying create a new empty draw image options, apply scale to 30% to each dimension, translate to 300 per 300, so this is the x and y coordinates, and then I'm saying draw. So let's see how this, it's example number 2. And you can see I have a card. Okay, that's okay, I'm drawing things on screen, making progress. There's one thing that I took a while to figure out why it was happening, is that the order of the operations are very, very, very important, because remember, under the hood, this is a matrix transform. A matrix transform, that means if I translate first and then apply a scale of 30%, I'm doing 30% of the translation as well. So you can see this, go build. I just reverse the order of translate and scale. And it's a little bit to top left. So just be mindful, if you want to scale the image just to draw on the screen, scale first and then do your things. Okay, moving on. This is drawing things. So, okay, I can't hard code every single image and thing, so of course we need to have a way to handle assets. So I'm basically using a combination of JSON and files, like PNG files for image mostly, and I have a couple of fonts, and I didn't get to the sounds part, but if you had sounds, I would use the same thing. And also, I'm heavily using Viper. Thanks a lot, Stevie Francier, for building this thing. This is amazing. We're going to see this in a moment. So let's look at card definitions. Card definition, this is the JSON format I chose to represent my card. So I have, it's a map, and I have like a card key, which is kind of the name in lowercase. I have a name, a type. I have effects, rules, asset. Asset is my file, my image. Count is how many cards I have in my deck. But the important bits here are effects and rules. And effects is, I'm using this so I don't need to hard code the rules. And I say, okay, if I play this card, are we back? If I play this card, I will get status oriented. And in terms of rules, I can only play this card if the target is myself, and it's me. Where's the crew? Crew, help. No need to. I didn't do anything, literally.
Same thing as last time.
Should be flickering.
There we go.
Okay.
Do you want to try that?
I'll try that again then later. Okay. We're back. Nice break. Okay, so, and I have rules that is the target of the card and what status I should have, or the title should be, so this card can be played. And I kind of take that an optimistic approach. When I select a card and make play, I will just say, yeah, take this card. I do a validation process, and if the validation fails, I just throw the card in the cemetery, in the graveyard or cemetery, whatever you want to call. And this is kind of the version of this thing in code. I didn't even bother using JSON struct tags, probably I should, but basically I use very simple names, and the tool takes care automatically. And this is my how I load the card. So I have this huge JSON file that has all the cards definition. And yes, I'm using a global variable, and this is an init function. I'm heavily using init functions because in the end, this is a game. If I miss an asset, I should kill the game, like log fatal and it's over because I can't play if I can't see the cards. And this is fine, so I use this a lot. I usually don't like panics and other kind of things, but in this case, there is not a clear separation of code and data. It's kind of both of them, like the data is part of the code in essence. Yeah, kind of functional programming way. Okay, so I have this very nasty global variable that has all the cards loaded. And here I'm loading all the images as well. And the configurations part, this is kind of the fun part. Because Viper, I'm not sure if anyone worked with Viper, but basically it allows us to load configurations. And it keeps checking configuration changes. So you can use this watch config function call. And basically, if I change something in the JSON file, click save, it automatically reloads my configuration. That's pretty cool, especially if you are prototyping something like this that you need to, oh yeah, let me see card position. Should this be 200 by 100 or 200 by 101? If you need to rebuild and load files and kickstart the program again, this takes a lot of time. But here, basically what we can do is, I just have the init function, loading Viper, and you have this Viper get something, which is the thing. And this you can use almost like a global thing. You can use anywhere in your code, and I can load the configuration. So in this case, what I did is I also created this helper function to resize to a given dimension because I didn't want to make this scale computations every time. But in the end, you see that my draw function basically has, OK, I'm trying to compute the size of the screen. That doesn't matter a lot. But here, when I'm drawing the card, I'm saying, every time I want to get the start coordinates, I'm just calling Viper. And here, also the same for the card dimensions, width and height. And let's see this how this works. So basically, cd, go build. Right. So basically, yeah, this is kind of was my board prototype, so I could place the thing. So I say, yeah, battle card, this should be around this place. But if since I'm using Viper, I can simply play around with the configuration and say, where's my config file? And let's say, oh, OK, no, this card is too large. Let's change to, I don't know, 100 to 150. Save, boom. And okay, oh, yeah, no, this coordinate doesn't look so nice. Let's see 400. And kind of, I can play around. And this is how I used to prototype the UI and check the position. So I have a huge configuration file with everything, and I was just playing around. And because, remember, the draw function is called 60 times per second. So it just next time it will redraw. Viper will reload. Of course, should I use this for the production deployment? Probably not. But for prototyping and developing, this is really great. Saved me a lot of time. OK, moving on. Game states. This is where things start to get fun because game is, like I said, it's a program that's running forever. You need to be able to control where you are with your game. So I have like an enter state, a title screen, a main menu, options menu. Then you, oh, OK, start the game. Then you have this inner loop here saying from turn start to turn end, which should be repeating until you have a game over condition and then back to title screen. So, OK, it's in the name. When you see states, you think about immediately states machine. So I tried this library called FSM, finite state machine. And because my original idea was, OK, let's do some event-driven architecture. I will have my state, and I'll get a key press event, and magically we'll move to the next state. But unfortunately, I hit like it's literally issue number three with that library is that he doesn't support multiple events with the same name. So I was not able to traverse the graph as I wanted. And eventually I thought, okay, actually I'm complicating things a lot. Let's just do the very standard traditional switch case with some states. And basically, if I want to transition automatically from one state to another, just at the end of my switch, next state, I set the next state and move on. In the next update call, it will be in the next state. If I want to have a more complex event handling, basically I can make it conditional to a key press or some kind of input, and then I only change the state in that event. So, and here's kind of, I did an abstraction because Ebiten, you can like capture keys with Ebiten, but I wanted to, I added an extra layer of abstraction because I want to control which kind of input I would get, and that would allow me to test better. So, for instance, and I have an input handler that is the keyboard handler. We will take keyboard presses. Okay, if I press enter, then move next. But let's say I want to do some tests. What I did, I created like a mock handler that basically I append a list of keys, key presses, and it pretends it's key pressing every time it's called. So that's how I used to automate some of the tests for these transitions. And here's the example. So this is my test for, so I have like a table-driven test with a struct with just a name for the test, initial state, a list of inputs, end state. And then in case of the ones that are automatic, I just pass new as my input. That's fine. But if I have some kind of need, I'm waiting for a key press, I put this here, and then basically I have this mock handler where I can append some keys and say, yeah, just most of the times I just append like an enter or something, and I call update once, and that's how I test. So it's a very simple trick, but with this I managed to test all the game logic in that update function. And here, just a short example. So this is how it looks like. So I have an update function with a lot of all the states, and here it's just everything is mocked. Like I just have like a small delay. Ta-da-da, ta-da, transition to the next step. And the same thing will happen with draw function, except that for the core of that game, that inner loop, I'll have a different drawing routine. I know that I only need to draw the board and the cards in this turn start, deal hand, draw phase, discard phase, and turn end. I know these are the states where I draw the thing. And here, I would have the opportunity to draw some kind of timed intro, which is none of them has been implemented for this version. So sorry about that. But let's see, just for the sake of it, quick example. Like this is just a quick state transition, then ta-da-da, and then game over. And then it will be here forever because I never implemented the go back to title. But the nice parts about here, this thing here is about the testing, how to test the transition. So basically, is the thing like before state, after state, and in later levels of the code, I have also the input handling, which is basically a nice way so you can get some test coverage on your main game logic. Okay, so this is the states. And now let's see, I'm not a huge fan of UML, but this was kind of like a way of seeing the design. So these are literally all the objects. Okay, maybe I'm missing the input handler here, but this are all the objects that compose the game. So basically, I have the game object here that implements the Ebiten interface. I have a player, so a game has two players. One is a human being, and the other is not so much. And then we have a deck, a graveyard that belong to the game, so these are the common objects that both players will access. And since Go doesn't have interface, doesn't have inheritance, I kind of abuse the type embedding structure so I can have some common behavior. And I implemented two types of things. One are the stack of cards, and the other one are the field of cards. Actually, the field object should be here as well, but stack is basically the stack mechanics: put, top, pop, and field is like because like the terrain stack, I only need to draw the top level card. Only the top level card is the one that has meaning for the game. That's why it's effectively a stack. Same thing for the battle stack, but for travel, all cards are important. So that's why it's travel field and not travel stack. And basically, we have these 5 objects that belong to player. That's so battle stack, terrain stack, travel field, defense field, and the hand, whereas the cards in your hand. And those are the ones that have card. And basically, the main logic of the game happens in the discard phase, where you basically read a key, where you're going to play the current card that are selected. So you discard that card from your hand, and basically here I do some validations of if my target is the opponent, then I call this play method with myself and the opponent. If the target is myself, then I call myself 2 times here, just from me to me. So this play method takes from someone to someone the card. And this is how play is implemented as of now. So yeah, if I'm playing a card to nobody, to nil, I put directly in the graveyard. Or if not, then I will call the receive method. So the receive is like I'm taking this card that someone played at me or myself played at me, and I'm going to apply the logic. If receive fails, means I fail some validation rule, and then that card goes to the graveyard. And the receive method is this. It's a huge method. Is where all the game logic is, almost all the game logic is, and that's where I validate those card rules. That's properties you saw in the JSON. And also, if I validated everything and I actually received that thing, I add to the respective stack or field based on its type, and then apply some additional effects if there are any. And for the drawing logic, I made the constant choice that every object should be responsible for drawing itself, which is, and also I'm abusing Viper a little bit here. So every object has its own configuration items, so they know where they should be drawn. So for example, stack types. Stack types I have this draw image method. A target is usually I call with the screen as parameter, saying, okay, draw this to the screen, and just get the top card of my stack, apply some resizing to make sure it's fitting the right time, the right size, translate to the actual position, remember the order is important, and call draw. Okay? Field types, almost the same thing, except I have an array or a slice of cards, and basically I have this additional step parameter, which is just so I could offset the cards a little bit. So, and then I multiply the X position by this step so I can have them side by side. I have some additional logic. For the hand is the same thing. I just have some additional logic to make sure you have a highlight on that card you have selected. But overall, this is how the player is organized. So I have a few properties. So I have all those, like the hand, the battle stack, terrain stack, travel field, defense field. I have my input handler that could be the keyboard or the mock, as I told you. And drawing is just, okay, I just need to draw all the elements I have. So I just broadcast the draw to the objects themselves. And when you put everything together, you have something like this. Sorry. Oh my, wrong window. Okay. Let's go build. And this is actually how the game works. So draw phase, you just hit enter, you draw a card, then I'm playing, puts in the battlefield. Actually, in this case, I'm hiding the computer movements, and the computer has a very smart AI. I'm kidding. It has no AI at all. I just press A. I'm just repeating send enter, so it takes any card and just plays. So I can play a card in their field. I can try to play cards on my field and travel a little bit. So it's kind of like this is the, so yeah, the computer just played a blue card here, and kind of almost works. So yeah, this is the prototype. And in terms of code, I just want to show you the game logic, and we have this. So the game itself is a bit more complex, but yeah, you can see. So I have the draw phase. I basically take a card from the deck and put in someone's hand. So it's kind of like, it's pretty simple actually when you think about it. It took a lot of time to get to this. And here, the thing about saying where's the discard phase? Yeah, here if you click on play, let's see the receive method. This is the things that didn't fit a slide is this, where's the receive? So I need to validate all the rules, say, oh yeah, is this a valid status? No, until you find one. Oh yeah, now it is. So it's kind of like this for every single rule, terrain, apply resistance, then compute travel, check if you're hitting any boundary, if you're overflowing the 40K, then put each card in its either stack or field, and then apply the resistance effects just in case you have any. So yeah, basically this is the logic, and I mentioned in terms of the intelligence of the computer, basically when I create the game, I use a lot this pattern of having a new function, even when I don't need one. I just kind of use as having a constructor thing. And basically I have this AI player that implements player, and basically I have I call it the dumb handler, which is just send a key after some delay. That's it, how I simulate the computer. And I think the last thing is kind of interesting in this code is the part about stacks. I have a basic stack type that has the common operations for stack top, put, pop, and I heavily use type embedding. So I just embed like a plain stack here, and that means I can expose all the methods to the battle stack, and then here I have the specific logic to that particular stack. So for instance, in battle stack, I'm only interested in the status it occurs, like the top level card status. That's what's important for me. And here, draw logic, again, abusing Viper so I could play around with the things. So yeah, this is kind of the game. It kind of works. Still needs a lot of refinement, sounds and things, and I'm using the old cards here. So yeah, what next? So basically, it kind of, when you have an actual artist working on things get really nice. So I was stalking this person on Twitter and asked, hey, what would be interesting doing some art for me? And she made this amazing drawing. And I kind of like, I think, the thing I learned about this game is that this was so fun in my childhood, but I did it so many times now that I kind of like, oh, this game is really crap. But seeing some art like this, I might be inspired to actually continue working on it. And learnings. Yeah, maybe I should not quit my day job yet. And really, this is something I heard a lot of people saying, like, your game's really only as good as your assets, so art is really important. And of course, you don't need to be an artist. You can hire other people to help you out, also sounds and music. Ebiten simplifies a lot, but you can see there's a lot of effort in building the actual game engine on top of Ebiten. And I really like this combination of Ebiten and Viper, because when I was very demotivated trying to, I need to find the coordinates, and then when I discovered that, okay, now my life is getting a little bit easier. And yeah, all the code for this talk is open source, it's there. And that's it for me. Thank you very much. Me. I'm not sure if I have any questions. Oh, I think I have someone there.
So I saw the cards are teleporting here or there, so you have like 0 animations. And normally, did you try to implement them? Because normally that's the part that can tell if the game engine sucks. Because if like everything is shining, sparkling, moving, that's where it starts to lag and you lose the FPS. So yeah, did you try to do animations? And
I tried experimenting, but I didn't get very far with it so far because I was still wrapping my head in the matrix operations. So definitely, just by scaling and translating repeatedly, it's kind of it takes a while to wrap your head around it. But yeah, that's the next step. Yes, I know it's still crap.
Hello, thank you for the talk. Do you think Go has features that are amenable to game design in general? And do you know of any of those features while you were working that you think make game design easy with Go?
I think Go routines and channels are something that's very useful. Especially, I didn't show here, but in my code to handle input was very simple because I just like spawned a Go routine to capture the things and would send to a channel that I could receive. So this whole thing, if think about, I want to spawn, I don't know, 5 AIs, just spawn everyone in your own Go routine. I think it makes it really simple to do this kind of thing. So I think that's my number one. And of course, garbage collector, other things, benefits you don't need to care about a lot. Yeah, you need to, but kind of less about managing memory. So yeah.
Given everything that you learned when you were going through this process, do you think you try to build it again? Do you think you try to sort of iterate on it? And if you could iterate on it, what would you do differently?
I think now that I know better how Ebiten works, is I definitely want to work on the animations part. I have some ideas for some timed animations, like if you want to run an intro, like timer after func, for instance, is a function that's amazing. Like you can, let's say you want to do a timed transition from one state, you just call time after func with some like closure that says, yeah, change my state after 60 seconds or something like that. And then you can start to build some animation scenes. I was trying to play with sprites as well and creating a sprite interface that will take the draw method. And I feel that if you can build this on an object called scene, add some sprites, it will simplify a lot the drawing routine. Like you just say, yeah, draw everything in the scene. I was aiming to that direction when I said, oh yeah, let's compose player with all the composing elements and delegate the drawing to the end object. That's where I was getting to, but if you use interface like a sprite interface, I think you can have a collection of sprites that compose your scene. So kind of like, yeah, playing on the animation, the drawing. And also, Ebiten makes sounds look like really simple. So I was trying to look for some sound assets so I could add, like I found like the card flip thing. So this will help bring life to the game, actually. Anyone else? No? Thank you.